Test, test. All right, everybody. We are going to start looking at matrices, and the first thing we're going to do is we're going to solve systems of equations by matrices, and these are going to be the same systems of linear equations that we've been working with. And so, with that in mind, and I'll talk to you about what a matrix is in a minute, but with that in mind, just as a reminder, let me give you a little example here. 3x plus 4y equals 1, x minus 2y equals 7. Remember, this is a system of equations. Sometimes they'll have the curly Q, sometimes they'll just give you the two equations. These are indeed both linear, right? The variables only have exponents of 1, so that's good. And what I want us to concentrate on for just a minute is what moves, I'll call it a move, are okay when solving systems of equations. And in particular, we're going to focus in on elimination. Okay, because that's the one that I use most of the time. That's the one I like. So we're going to focus in on that because the moves are important. Because if it's okay for me to do it when I'm solving a system of equations using the equations, then when we get to matrices here in just a second, it'll be okay to do that move when we do matrices. So I want to make sure. So first of all, we didn't do this last time, but I have a question. Here's my system of equation. So is this equal to this system of equations? X minus 2y equals 7, 3x plus 4y equals 1. Okay, so what did I do first of all? And then is it okay? Did I mess anything up? Did I change any values or whatever? So first of all, what I did was I just swapped rows, right? Swapped the rows. Okay, so equation number 1 became equation number 2 in the order, right? So here I had equation number 1, equation number 2. Now the equation number 2 is equation number 1. Equation number 1 is equation number 2. I switched their order. Okay. I just swapped them. Does it matter? Is my question. No, it does not matter. This equation is still all together. X minus 2y equals 7. It looks just like it looked up there, right? And this equation, 3x plus 4y equals 1, it looks just like it looked up there, okay? So it's perfectly, I'm going to call them legal moves, okay? It's perfectly legal for me to swap rows or to swap equations, the order, right? What I couldn't do is I couldn't say something like 3x plus 4y equals 7, right? I can't mix and match, in other words, so that would be bad. But as long as I think of this is a row all by itself, okay? This is a row all by itself, and I do the same thing all the way through the equation, I'm okay. Okay, which leads me to my second point. Last time I said, oh, let's multiply this top equation or the top row by something that'll allow me to eliminate I'm going to pick on, let's pick on the y's actually, because the negative here and the positive here, right? So I can pick on the y's and I can multiply by a 2 all the way through that first equation. Boom, boom, boom. Is that okay? Yes. So I can multiply one equation by a number. Okay, we haven't done this, but you can multiply it by fractions. You'll see that as we go through the matrices. I could have multiplied this by, instead of multiplying this by 2, I could have multiplied the second row by 1/2, and that would give me 4 divided by 2 would be a positive 2. Why don't I do that? Well, I don't do that because I don't want to have 3 over 2, and I don't want to have to have 1 over 2. just to get a 2y here. So I don't want to deal with fractions any more than I have to. So, but I could have multiplied that. What I can't multiply is I can't multiply through by 0. Why not? If I multiplied this through by 0, what would happen? 0, 0, 0. Everything would go to 0, right? Okay, so that would just basically get rid of or eliminate that entire equation. Well, I can't do that. I can't dump the whole entire equation, but I can multiply the whole entire equation by a 2 or by a 1/3 or by a -7 or whatever, right? So I can multiply one equation by a number. In fact, I can multiply both rows by a number if I wanted to, right? So any not negative, not 0 number, I am okay. All right, I need to distribute that through, so let's do it. 2 times x is 2x minus 4y equals 14. Okay, and then here I didn't do anything to the second row because I already have a plus 4y there. So I just rewrite it. I'm happy to do that. You're going to get used to, if I didn't do anything to it, just rewrite it. It's okay. I'm trying to eliminate my y's here, right? And to do that, I need to add. So I'm going to add these two equations together. So 5x, this becomes a 0, equals 14 plus 1 is 15. All right, what did I just do? I added 2 rows together. Variable by variable. And I added the constants by themselves. So in other words, I can't add the x and the y, right? They have to be lined up. This is an x, this is an x. Those are like terms. 2x plus 3x is 5x. I'm good there. Negative 4y, positive 4y. Those are like terms. Add them together. These are just constants sitting out here by themselves. 14 plus 1, that's a 15. I can add those together. So I combine like terms basically, right? Okay. And then once I'm done with that, I end up with this thing where this y value has gone away, and I've got 5x equals 15. My system of equations just dropped out, right? So the system is gone, and this is just an equation, and I want to divide by 5. That's okay. X equals 3. That's what we know this is going to be by elimination. That's actually not really a step for a system because I was just dealing with one variable, one equation all by itself. But if it was anything, I could multiply one equation by a number and I could multiply by fractions, right? So technically what I just did, I divided by 5 right here. But that's the same as if I had multiplied by 1/5, right? I could have done that instead, and that would have still canceled out that way, reduced. Yeah. Okay. So, and same thing here. I divided by 5, but I could have done 15 times 1/5 and gotten a 3. So dividing by 5, multiplying by 1/5, those are equivalent, right? Okay, so these are the 3 things that I can do, and they're gonna be called row operations as I move forward. I can swap rows. I can multiply one row by a number as long as it's not 0, and that includes fractions. And I can add 2 rows together, variable by variable, and adding the constant to the constant. Okay, so that's what I've got. I came up with x equals 3. I'm not finished with this one. Let's just real quickly go back and finish it. I need to plug in the x equals 3 somewhere, so I'm going to plug it into this second equation. So I've got x minus 2y equals 7. Yeah, and I'm going to plug in a 3. Okay, I'm going to subtract this 3 off, minus 2y equals, I'm subtracting 3, subtracting 3. That's a 4. Y equals -2, right? So I think my solution here is going to be 3 and -2. Okay, and we worked that all the way out with elimination because I want us to have like somewhere to look whenever we start doing matrices because we're going to compare because Just like when we did substitution, just like when we did graphing, just when we did elimination, they're different methods, but we better end up with the same answer, right? No matter what happens, we better end up with the same answer. So hopefully, when we do this question in a minute using matrices, once we know what a matrix is, we will be okay. Okay, we'll get the same answer. If we do, we're home free. All right, so what's a matrix? I keep on using that word. Your book and many books actually talk about augmented matrix or an augmented matrix, or matrices is the plural. Okay. And here's the way it's going to look. Basically, what we're going to do, let me pull this guy down. We are going to have a system of equations, just like what we had a second ago. But we're going to work with it without the variables. Okay. It's supposed to make it faster and easier, and often it does. Okay, so let me put this system of equations. It's the same one we just did. 3x plus 4y equals 1, and x minus 2y equals 7. Okay, and we're going to put it into a matrix, but we're not going to write the variables. We're just going to deal with the coefficients, so to speak. Okay, so it's going to look like this. I'm going to have my first equation on the first row. I'm going to have my second equation on the second row. So I'm not switching order or anything crazy like that. But what's going to happen is the first column of my matrix, columns are vertical, rows are side to side. So my first column is going to be all my x variables, their coefficients. The second column is going to be all my y variables, their coefficients. And then for the augmented matrix, we have this little dashed line that comes down here. And then the matrix, there's a third column here, and these are going to be my constants. Okay. So when I have this set up in kind of like this standard x plus y equals a number, ax plus by equals some constant. When I have it set up in that kind of format, it will go very nicely into this format. Okay. But what we have to remember is these are all just going to be numbers. This is going to be number, 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 number. And there's going to be two coefficients back here, or two constants back there at the back. So my x coefficient, what's going to be there? The coefficient is a 3, right? I'm going to stick it right here. Okay. The y coefficient in the first equation, what's it going to be? 4. Okay. And what's the constant? 1, right? Kind of out of space on this paper, so I'm kind of trying to squish it in. Okay, what's the coefficient for the x here? There's nothing written there, but we know there's really a 1, right? And what's the coefficient here? Be careful. It's -2, right? And what's the coefficient or the constant number there? 7. Okay. So this is what my augmented matrix is going to look like. And the augmented part comes because I've got the the constant terms out here, right? Sometimes we'll see matrices and they're just like a 2 by 2, just the variables thing. But because I've got the solutions, the equals part over here, the constants, because I've got that now, okay, cool. I've got an augmented matrix. That's what's going on there. Okay, so what's going to happen here? We are going to have things that we call row operations. Okay, row operations include, okay, there are 3 of them, 3 basic row operations. 1, you can switch 2 rows. Okay, well, we just talked about that. Does it matter if this equation's on the top or this equation's on the top? It doesn't matter. Okay, as long as you keep everything together. So I can switch 2 rows. So what would that look like with this guy right here? If I switch 2 rows. Well, there's only 2 rows. So basically I'm saying put this bottom on the top, 1, -2, and 7. It has to be the entire row because what we're going to remember is this represents the entire equation, right? So they have to stay together. 1, -2, and 7. And on the bottom, I could write 3, 4, and 1. Okay. I can't change the values. Okay. When I'm switching rows, I just swap the rows. Okay. But I can change the order equation. Now, this was my original equation number 2, right? Okay. Now he's on top. That's okay. They just swap the rows. That's all right. Okay. So that's one allowable row operation. Okay. So let's go back. We switched the rows. Okay. Then what did we do here? Okay. I multiplied the top row. Okay. The new top row, right? 1, -2, 7. That's on the top now. 1, -2, 7. I multiplied it by 2. Okay. And I distributed that all the way through. So row operation number 2 is you can multiply any row by any non-zero number. Not 0, can't multiply by 0, but I'm gonna multiply by any other number I want to. And what we multiplied by was a 2. So what you're gonna see me do is you're gonna see me multiply, see me say, like, there's a 2 there, and I'm gonna multiply it in, okay? So there's some notation for that, and it looks a little mathy. It looks kinda like this. Row 1 becomes row 1 times 2. Okay. I don't really care if you know that notation, except that I'm pretty sure it's in your My Math Lab like that. So I want you to see that. But all this stands for is row 1. Row 1, R1 is row 1, and instead of it being just the 1, -2, 7, we're gonna multiply it times 2. And so my notation is just gonna be put it right there and no problem. So here we go. I'm just gonna multiply that guy by a 2 on the top row. 1 times 2 is a 2, -2 times 2 is a -4. Put your dash line in there. 2 times 7 is a 14. Did I multiply the bottom row by something? No. 3, 4, 1. I just rewrite it. It's just along for the ride. And look here. Okay, I've got 2, -4, 14. When we did this, we had 2, -4, 14, and the bottom row stayed the same, right? 3x plus 4y equals 1. That's going to be represented here by 3, 4, and 1. Okay, no x's written there, but we all know this first column is my x's. This second column is my y's, and this third column is my constant numbers, or the numbers that are on the other side of x equals, right? Okay. So the third possible row operation is I can multiply any row by a number, by a number, and add it to another row, replacing that row. Okay, replacing that row. All right, so this is where it's going to look just a tiny bit different than what we did with the other. Before, we actually eliminated both of these, right? But we're not going to do that. Instead, we're going to say, hey, look, I've got this guy. He's a -4, just the way I want him. And I want to replace that guy down there. Okay. So you can do whatever you want there. You can multiply by a 1 if you wanted to write it that way. I always do it like this and say I'm going to add it down. Okay, that's kind of my notation. To show this isn't actually how I would really solve this equation, but that's kind of where we got from the other one. So I'm going to show it to you. To do this, what we're going to do is I'm saying multiply by 1. I'm really just going to, because multiplying 2 by 1 is just a 2, right? I'm really just going to add this down. Okay, that's where I'm headed. The notation that you'll see for this um, in your my math lab is row 2 because I'm going to change row 2. Row 2 equals 1 times row 1 plus row 2. Okay. 1 times row 1. You could put parentheses if you want to. Plus row 2. I don't really care about the multiplication here. I'm just adding them down. So did I change that top row? No. 2, -4, 14. Okay. Whenever I do this, though, I've got 2 plus 3 is 5. -4 plus 4 is 0. And 14 plus 1 is 15. Okay. This is the situation. This is exactly what we had whenever we solved this with elimination. Let me show you that first. So here I've got this. Okay. 2, -4, 14. I didn't do anything with that. But what we ended up with was 5x plus 0y equals 15. And look, 5x plus 0y equals 15. That's this bottom row. Okay. What we're going to do right now is not the way I would solve this with the matrix by itself. I'm just trying to make this line up with what we did so you'll see it. The cool thing for this is one of these the y variable here got eliminated, right? Just like I did whenever I was working with elimination. Okay. So the kind of cool thing is because I have that, I can drop down now and say 5x equals 15 because this is a 0 now, right? I can read this second equation, 5x equals 15. That's what I've got. And because the y's are gone, or the y is gone out of that one, it becomes easy for me to say, well, x must be 3. Okay. And then we can go back and substitute in and get our y equals -2, just like we did before. Okay. Substitute for y equals -2. You go back to the original. Okay. So absolutely, we can work it just the exact same way that we had for elimination, and we can interpret this matrix 5x plus 0 equals 15. Hey, look, 5 and 15, those 15 is a multiple of 5. I can solve that real quickly. So we can indeed take out this one equation and say, oh, let me solve this guy. 5x plus 0 equals 15. Put it down there. X equals 3. Okay. If I do it this way, I have to go back and substitute for in the original for the y equals -2. Okay. So that lines up with elimination, and that's all awesome. But a lot of times we don't want to have to go back and do it just the way we did it in the elimination. There's a power in matrices that we want to harness here. Okay, so we can do it like that if we had to, but I was just doing that to show us the 3-row operations. Okay, switch 2 rows, multiply any one row by a non-negative number, non-zero number, and then multiply any row by a number, again, not 0, okay, and then add it to another row. Not 0. Add it to another row, replace that other row. Okay, those are the 3-row operations, and we'll see it come along as we go along. But for my augmented matrix, there's a really cool process that will work every time. So if this guy is a solvable matrix, meaning that I have solutions here, okay, then what I can do is I can get it into, this is called a reduced format. Reduced format. Okay. And if I can force it to look like this, exactly like this, 1 0 and a number. Okay, let's interpret that. What would that say? 1x plus 0y equals some number. So x equals a number. Hey, that's cool. That would be easy to read, wouldn't it? 1x equals a number. And then what about this bottom row? 0, 1 number. So 1y equals a number. Literally, just reading this out, you would have, this would say x equals this number, and this would say y equals that number. Isn't that nice? If I could get it to look like that, it would be so, so nice. Okay. So the process of matrices is we're going to take and By and far, we're going to work with 2x2 matrices. We might throw in some 3x3s at the end. And the 2x2, we call that right here, looking at this part without the equals constant part on it. Okay. That is a 2x2. Okay. 2 rows, 2 columns, right? 2 rows and 2 columns. It's square. Okay. That'll come up later whenever we deal with matrices a little bit more, but this guy's square. Okay. He's a 2x2. So whenever I'm dealing with that, if I can get it into this reduced format, 1001 like this, that's really nice. It reads so pretty. So x equals some number, y equals some other number. But the deal is there's a process you have to go through to get to this. You've got to get, well, I don't say got to, you can do it in other ways, but if you do, you're going to be doing extra work. I've got to do it fast and easy. I've got to get this first guy, this first equation, first variable, so x in the first line. I need it to be the 1. I need to do that first, okay? And then the second thing I'm going to do is I'm going to make this guy be a 0. Okay. And I'll show you how in a minute. Don't worry about it. Don't worry about that actual, how does that work? But I want to make this guy be a 0 because once this guy's a 0, it won't matter what I do. Anything times a 0 here on this second row is just going to be a 0, right? Then I'm going to make third this one. Okay. And the last thing I'm going to do is I'm going to worry about this y value being a 0. Okay. So that's the order I'm going to do it in. I kind of think it's like going counterclockwise. Start at the top left, go down, over, up, down, over, up. It makes this little square. Okay. You'll get used to how that feels as we go along. Like, okay, what's the process? What's the pattern that we're looking at? It's going to be in that order every time I do it. Okay. Every time I do this, that's what it's going to look like. All right. So let's go back to this example. 3x plus 4y equals 1. X minus 2y equals 7. Okay. That was my system. Okay. Go ahead and write your augmented matrix just the way we had it. We've already done this, so you should be able to do it really pretty easily. First row is going to be 3, 4, and a 1. All right. And the second row is going to be a 1, a -2, and a 7. Okay. My biggest complaint about matrices is not doing them. It's that they take up so much paper. Okay. So if you can start kind of squeezing these together, don't write them huge. It will help. And I like to do little arrows. Okay. So this guy is going to go to this next guy, which I'm going to put right down here. And again, I'm going to try to, if I can, I'm going to try to get a couple of these matrices on a row. I've seen people do a real good job. I don't want you squeezing it down so I can't read your handwriting, but I've seen people do a good job of putting 2 or 3 on a row. That's pretty nice. Okay. So let me go back to this sheet. The first thing I do is I want a 1 right here, top left. Hey, look, bottom left is a 1. Okay. So is it okay? Is it a legal move for me to swap those 2 rows? Yes, Dr. Webster. Absolutely, it's legal. So I'm just going to swap them. Okay. As long as you make sure everything stays in the right position. So this row was a 1, -2, 7. I'm putting it on top, 1, -2, 7. And this row was 3, 4, 1, and I put it on bottom 3, 4, 1. So don't try to make sure you don't make copy errors. Okay. That's like a typo. It's really easy to do. Make sure you keep all your negative signs. It was a -2. This is a -2. That's a -2. So watch out for stuff like that. Make sure that everything in the same equation stays on the same row here so that they're all together. The 7 doesn't end up with the 3 and the 4, things like that. Just be a little bit careful. Oh, excuse me, as you do this, but we can do it. It's okay. All right. So what does that tell me? I've already got the 1. Hey, first guy is done. Second guy, I need a 0 down here. So let's see what we can do. Okay. I want this to be a 0. I want that 3 to be a 0. Right now it's a 3. But if I multiplied the top row by -3 and added it down, what would this be? -3 times 1 is -3. Add it down through -3 plus 3 is a 0. Okay. Now here's the trick though. I don't want to change the top row, right? And I'm not going to change the top row. So what I highly, highly recommend is before we do this, go ahead and write down your top row. So you don't forget, hey, I want that 1 to stay there. 1, -2, 7. I'm not changing the top row. I'm changing the bottom row because I want this guy to be a 0, right? So be careful with that. I think to myself, hey, you're still distributing this -3 through, so make sure he goes to all the terms. So -3 times 1 is -3 plus 3 is 0. Hey, that's what I wanted there. I wanted a 0. And then the rest just kind of falls into place. -3 times -2 is a positive 6. 6 plus 4 is 10, right? -3 times 7 is a -21. -21 plus a positive 20, I'm sorry, -21 plus a 1 is -20. And if you need to, you can kind of do some of this scratch work off to the side or use your calculator, that kind of thing. Okay. So that's what I wanted to happen here. I wanted a 1 and a 0. And then the next step, I want this one. So I'm making my way around the square here, right? Ignore the constants back there. 1, 2, 3. I want this guy to be a 1, right? Remember that? Okay. First, second, third. I want this guy to be a 1. So I'm coming back to that augmented matrix, what I want it to look like. Hey, hang on a second. Okay. Ignore the top row. In fact, I'm not even messing with the top row. So I'm going to rewrite the top row real fast. 1, -2, and 7. You're staying the way you are. Look at that bottom row, and if you need to, cover up the top row so you're not looking at it or it's not confusing you. There's lots of stuff going on here, right? That bottom row, remember that represents an equation. Right now it says 0x plus 10y equals -2. -20, sorry. And I want that guy to be a 10. What can I do here to that 10 to make him be a 1? I want this to be a 1. I think I didn't say that right. I'm sorry. I want this 10 to be a 1. That's the position he's in. It was 1, 0, 1. So what can I do to the 10 to make it into a 1? In my head, I'm thinking 10 divided by 10 is a 1, right? 10 divided by 10 is a 1. But dividing isn't one of my row operations. But what's equivalent to dividing by 1, dividing by 10, is the same as multiplying by 1/10. Think about that for a second. Okay, just focus in right here. If I multiply by 1/10, first of all, what's going on here? 1/10 times 0, that's just going to be a 0. That's why I said make that guy a 0 first. It makes our life easier. 1/10 times 10, what's that? Well, that'll be 1 times 10 on the top, 10 times 1 on the bottom, 10 over 10. That's going to be a 1. That's what I want it to be. And then don't forget to distribute all the way through. Every once in a while, I see people and they forget about this constant term over here. It also has to be multiplied by whatever term, right? So be careful with that. But hey, I think I've got a 0. 1/10 times 10 is a 1. And 1/10 times -20th is a -2. Be careful because he's negative, right? -20 times 1/10. Or 20 divide by 10 if you want to say it that way. But it's technically going to be times 1/10, right? Hey, look at that. Now I've got the first guy's a 1. The second guy's a 0. The third guy's a 1. Hey, we're making progress, right? Now I need this one up here, right? 1, 0, 1, 0. I need that fourth guy to be a 0, okay? Now, the way I'm gonna do this, and it's gonna be the same process every time, so be careful, is again, now I'm gonna start working off the bottom row, okay? The bottom row is exactly what I want it to be right now, right? 0, 1, -2. I don't care what the right-hand number is. I just care that it's a 0 and a 1. So I do not want to mess this up. Okay. So I'm not adding anything to the bottom row. I'm going to leave that bottom row the same. In fact, I'm going to go ahead and say, okay, this is going to go to, I'm going to make my new little brackets here. And I'm going to say this bottom row is staying 0, 1, -2. Okay. Because I don't want to mess him up. I want him to stay the same because those are the numbers I want there, right? Okay. But what's going to happen here is whenever I come up here and I'm working on this, I need to do something to this bottom row, okay, that will, I can multiply it by something and add because I want to eliminate this, right? I want a 0 here, okay? 1, 0, 0, 1, 0, 1, 0. That's what I'm up to. I want a 0. So what can I do to the bottom row? I'm done with all this stuff. Ignore it. What can I do to the bottom row here? And it needs to be a multiplication that I can add up here and make that a 0. Well, -2 plus what is 0? -2 plus 2, right? Okay. Remember, I'm not changing the bottom row. I'm just trying to make this be a 0. The beauty of the order in which we did this is by making this be a 0 first. Now I'm going 2 times 0. I'm going to distribute this, right? Okay. So that I can add them up to the top. 2 times 0, what is that? 0. So whenever I do 0 plus 1, it doesn't change this 1. If you do this in different orders, you're going to mess up your 1. So by doing it in this order, 2 times 0 is 0. 0 plus the 1 is a 1. It keeps it there. Okay. 2 times 1 is 2. 2 plus the -2, that's a 0. Hey, look at that. Isn't that exactly what I said I wanted? 1, 0, 1, 0. Absolutely. Okay, so that's beautiful. Finish it out. Ignore this stuff here, right? 2 times -2 is -4. -4 plus 7 is -4 plus 7 is a 3. All right. All right then. Okay. So here's what I got from that. First of all, did we get the right answer? Well, yeah. Earlier when we did it by elimination, we had 3 and we said we're going to get -2, right? So how does this read? Literally, x plus 0y equals 3. X equals 3. That's how I read that one. Just ignore that. X equals 3, right? What about this one? 0x plus y equals -2. We'll ignore that one, right? We don't care about that. We got negative y equals -2. Sorry, I read it backwards. Okay. That's what we wanted, right? That's my solution. 3, -2. That's it. That's my solution. All right. Now, I kind of crammed this together and I got that whole problem into about a half a page. Sometimes, if we're not really paying attention and we kind of write big and stuff like that, we can indeed use lots of paper. So just watch out for that. But the beauty of the matrix is this right here. X equals 3, y equals -2. Man, that's pretty. Ooh, excuse me. That's really, really pretty. So if you can do it like that, that is amazing. And you will have good things coming out of it, right? Okay. All right. So really nice. Okay. Let's do another one. I'm not going to do this one with elimination first. I'm just going to do this one working through and see what we get. Okay, so we'll see what we get. Okay. For some reason your book all of a sudden says let's start doing 2x sub 1 minus 3x sub 2 equals 6. And x sub 1 plus 2x sub 2 equals, I'm sorry, hang on. Ooh, I wrote that wrong. 2x sub 1, I got into 2 different problems here. 2x sub 1 minus 3x sub 2 equals 6. That was correct. I apologize. This bottom run, I went onto the wrong problem. 3x sub 1 plus 4x sub 2 equals 1/2. Okay, that's my system. Sorry about that. Just looked up and grabbed the wrong problem. Okay, so I don't know why all of a sudden it's swapping over to x sub 1s and or x sub 1s and x sub 2s. I think it's just trying to make a point that, hey, we're in a matrix, so they look a little bit different. In fact, in the book, they'll be like, this is your x sub 1 row, and this is your x sub 2 row. And if we had like a 3 by 3, this would be your x sub 3 row, and then this would be your coefficient, and this would be equation 1, equation 2, and equation 3. Okay, we're not going to do 3 by 3s right now, but you'll see them with this notation x1, x2, x3. I pretty much say ignore that because we are almost always going to say this is x and this is y. And what do you think the third variable is going to be? Z. Yep. X, Y, and Z. Okay, so when we go to 3 dimensions, which we're not there yet, when we get to the third 3 by 3s, it will be X, Y, and Z is what I'm normally going to deal with. But they've got this as X1 and X2. It just means this is my first variable, this is my second variable. Don't stress out about that, okay? In fact, the nice thing is, because we're about to put this into an augmented matrix, we don't even care about those variables anymore, right? So this is going to be what on the first row? If you say it to yourself, say it out loud with me, whatever. The first is going to be the coefficient for the x is a 2. The coefficient for the next guy is a 3, and then my dotted line, and my constant out there by itself is a 6, right? 2, -3, 6. Watch out for those negatives. And on the second row, I've got a 3, I've got a 4, and I've got a 1/2, right? Okay. So that is indeed what I'm seeing here. There's my augmented matrix. Okay. Well, I want to make this so I've got um, a 1 up here on the top, and they are not making this easy for me, right? Because when I look at this, I've got a 2 here. If I were to divide by 2, I'd be okay on the 6, but I'm going to end up with a fraction there. And unfortunately, sometimes fractions happen, guys. Okay. So I think that probably the easiest way for me to get a 1 right here at the beginning, because remember, I want this to be a 1 to begin with, is to multiply the top row by a 1/2. And I know it gives me a fraction, but I think it'll work its way out. Don't stress out. I already have a fraction down here, right? That guy's a fraction already. So, all right. Am I doing anything to the second row? No, it's a 3, a 4, and a 1/2. So I'm just going to leave that second row alone. I'm only multiplying the top row by a 1/2. So 1/2 times 2 is 1. 1/2 times a -3 is -3/2. And 1/2 times 6, that's a 3. Okay. Like I said, sometimes fractions just happen and it's okay. Um, we'll be okay. We'll get there. All right. So here I am. Ignore that first guy. We don't care about him anymore. We're at this guy. I'm going to come down to a second row here. I want this piece right here to be a 3. Cover it up so you don't look at it. If it's too much stuff going on and it messes you up, just cover it up. I don't want to change this 1, so I'm going to write the first row. 1, -3/2, and 3, because I don't want to mess it up. I want that 1 to stay where it is. But what I want to do is, what can I multiply by 1 and add down to that 3 that'll make this a 0? I'm after a 0 here, right? 1, 0, 1, 0. So in my head, I think what will eliminate a 3? -3, right? -3 plus 3 is going to give me a 0. So that's the number I'm multiplying through, and we're going to distribute it. Okay. So -3 times 1 is -3 plus 3. That's a 0. Okay. Negative 3 times negative 3 halves. A negative and a negative is a positive. This is 3 over 1, right? So that's 3 times 3 is a 9. 1 times 2 on the bottom is a half. We still got a fraction going on. It's okay. And then negative 3 times positive 3 is 9. Be careful here because 9 plus 1/2. I'm adding these down. Let's do that real quickly. 9 plus 1/2. I need to get common denominators. 18 over 2 plus 1/2. That's going to be 19 over 2, right? I'm not too stressed about it. I think it'll be okay. Don't worry about it. All right. So this is the new matrix that I have. I've got the 1, I've got the 0, and I need a 1 right here. This guy needs to be a 1. All right, but he's a 9 halves, so it's actually going to make it nicer when I do this, but it's going to look ugly. What can I do to 9 halves to make him be a 1? I want a 1, a 0, and a 1 here. And with your fractions, hopefully we know, let me just keep on with the scratch work over here. Hopefully we know if I have 9 halves and I want to multiply it by something to make a 1, the fraction that I need to multiply by is the reciprocal, right? 2 over 9, because the 9s will reduce out and the 2s will reduce out, and that'll be just a 1. Okay, so what I want to multiply by out here in the front is 2 over 9. And I'm going to multiply it all the way through here on the bottom. Now, what am I trying to change? I'm trying to change the bottom. Am I trying to change the top? No. So before I do anything else, and I think it's really important if you can do this, think to do it, so you're not confusing yourself. I'm rewriting the top row because I want that top row to stay like it is for right now. I'll mess this up in a minute. This guy will become a 0. But for right now, I'm just trying to make this bottom row be a 0 and a 1. So 2 times 0, 0, right? So that's the beauty of putting that 0 there. It doesn't matter what I multiply by. It's still a 0 there. I'm not messing anything up. 2 ninths times 9 halves. That's the 1 I'm after. See right here how it works out. And then I'm going to multiply right here 2 ninths times 19 over 2. It's not as bad as it looks. The 2's will go away. I've got 19 over 9. That's not bad. It'll work out. All right. That's not horrible. Okay. And then hang on just a second. I'm going to check something. I want to make sure my math's good. I see what's bugging me. And see, if we were face to face in a class, you would have caught this and told me that I was messing it up. But nobody said anything because y'all aren't here to talk to me face to face. So let me come back just a step. I apologize. I'm going to X this out. I'm sorry. I know this is where we go. We have to be really careful with our math. Right here, I multiplied -3 times 1 and added it down. -3 plus 3 was a 0. -3 times -3 halves, I get positive 9 halves. That's correct, but I need to add it down, and I didn't. I just brought it down right here. Okay, so let me see. I'm sorry. It's 9 halves. -3 times -3 is 9 over 2. Okay. Plus the 4 over 1. That's an 8 over 1, right? I'm sorry, 8 over 2. 17 over 2. Okay. So I didn't add the 4. I apologize. So, positive. I'm just being careful because I don't want to mess it up again. So negative times a negative gave me positive 9 halves. 9 halves plus 4. 9 halves plus 4 is 17 over 2. Okay. And then let's just double check here. -3 times 3 Oh, I went the wrong way on this one, didn't I? -3 times 3 is -9, -18/2 plus 1/2, that's where it is, -17/2. So -17. That's gonna be a lot nicer. Okay. I was like, "Ooh, I don't remember this one being this crazy." There we go. Okay, so I apologize about this one right here, and that's why we use calculators instead of depending on me doing it in my head. Okay, so what I've got, let me recopy this after I multiplied. So I haven't multiplied by the 2 nines yet. After I multiplied the top row by -3 and added it down, I had 1, -3/2 and a 3, 0, 17/2, and a -17/2. That makes life much nicer. Okay. Because I was like, ooh, that's not turning out pretty. The 19/9 was not what I wanted. I knew. Okay, so now I look at this guy and I say, what can I do to 17/2? Same process as I said a minute ago, but with a different number. What can I do to 17/2? Because I want this guy to be a 1, right? I want that piece right there to be a 1. Okay. What can I multiply it by? I can multiply it by 2/17, right? Because that will cancel out top and bottom. That will reduce it down to just a 1. That's what I'm after. So I'm going to multiply this guy out in the front by 2/17. But now it's going to be so much nicer because both of these are going to cancel out, reduce down, however you want to think about it, right? So here we go. This goes to. Did I mess up the top? Did I move anything on the top? No. Leave the top alone. Don't mess it up. Okay. What I'm moving is I had the 0 here, 2/17 times 0, and the 2/17 times the 17/2. That makes this guy a 1. That's what I'm after, remember. And then the 2/17 times the -17/2. That's a lot prettier than 19/9 was, right? That's a -1. Yay, we like that better. All right. Whew, now we're in the home stretch. Okay. We want this guy right here to be a 0. We went 1, 0, 1, 0. And we have to multiply the bottom by something and add it up. Well, it's a +1 and -3/2. I'm going to multiply it by a +3/2. That will make that be +3/2. And when I add it out, that will eliminate that -3/2, right? All right. So am I changing anything on the bottom row? No, I love the bottom row. It looks perfect right now. Okay. 1, 0, 1, and -1. I love it. Okay. Whenever I multiply by the 3/2, that's a 0 plus a 1. That better stay a 1, right? I don't want to mess anything up here. But now I've got 3/2 times 1 is 3/2 plus -3/2. There's that 0, right? And then the only thing to be careful about here is this is a -1 times 3/2. So this is -3/2. And again, I might need to do a little bit of arithmetic off the side. -3/2 plus a 3 is 6/2, right? -3/2 plus 6/2, that's 3/2, right? So it did work out itself out in the end. I didn't have ridiculous fractions until I got 19/9, and I should have known then something was wrong. I just didn't add. I'm sorry. But here we go. 1, 0, 1, 0. This is the way I want it to look. It looks beautiful. I apologize. All right, so let's read it. X equals what? Top row. X equals 3/2. Y equals what? That's the bottom row. Y equals -1. If you want to put it as a point, it looks like 3/2, comma, -1, right? Okay. All right. Then let's do one. I'm going to write it up and you're going to we'll write together the augmented matrix and then hopefully everybody can work it on their own and see how it looks. Um Here's my example. I'm going to use the book notation. It's not lovely, but I want you to kind of see it. Okay. 2x sub 1, again, that just means the first variable, minus x sub 2, that's my second variable, equals -7. If you want to, you can call this x and y. It's the same thing. And the second guy is x sub 1 plus 2x sub 2 equals 4. That is the system of equations, okay? So let's start it out together by writing the augmented matrix together. I think it should be 2, -1, -7, and 1, 2, 4. Is that what you got? I hope that's what you got. Okay, so that's the beginning. Remember the order. We want a 1, then a 0, then a 1, then a 0. And I'm going to push pause and I'm going to work it, and you push pause and you work it, and I'll put it all up in just a second. All right, so I actually ended up with a pretty nice solution here. I saw right off I wanted a 1 right here. So I just switched these two so that the 1 was on the top, 1, 2, and 4. Make sure you keep your rows together, right? And then I wanted a 0 here, so I multiplied the top by -2 and added it down. I'm noting I left the top row alone. Don't mess with it. It's got the 1. I want it to stay there. So -2 and 2 is 0. -2 times 2 is -4, and -1 is -5. -2 times 4 is -8, plus -7 is -15. Oh, that looks nice on the bottom row. I want a 1 right here. So -1/5 is what I multiplied by, or you can think divide by -5. It needs to be negative though, because there's a negative. I need to get rid of it. So a negative and a negative becomes the positive. 5 divided by 5 becomes the 1. I also have a negative and a negative when I multiply by the 15. -15 times -1/5. That becomes a positive. 15 over 5 is a 3. Okay, so that's nice. So I've got my 1 there. And then I need this top guy, tops first row, second column. I need him to be a 0. The bottom row is exactly how I want it, so I leave it alone. 0, 1, -3. I'm sorry, 0, 1, and 3. And I'm going to multiply the bottom row by -2 and add that up to make this guy work out nicely. So 0 plus 1 is 1. -2 times 1 is a -2, plus 2 gives me the 0. -2 times 3 is -6. When I distribute that got through. -6 plus 4 gives me the -2. So this is actually very nice and easy to read. This gives me x equals -2. And this bottom row gives me y equals 3. And so I've got the point -2, comma 3. That is a beautiful little solution for that system. Ends up nice, even though we might have thought, ooh, we had to multiply by a -1/5 in there. That's not horrible. Okay, it ended up okay, which is good. All right. So hopefully you were able to do that one by yourself and it wasn't too horrendous. I think if you stick with the order that I told you, this one first, this 0 second, this one third, this 0 fourth, I think if you'll do it in that pattern every time, it will save you. I see a lot of students that like make this a 0 and then they go back and they add something down so that they can get the 1 here, but that makes that not a 0. So once you've got that 0 in place, you want it to stay there. Once you've got this 1 in place, you want it to stay there. So make sure you're not undoing math you already did. So we wanted a 0 there for a reason, so keep it there. Okay, we can multiply that 0 by stuff, but we can't add to it without messing it up. Okay. All right, so that's a couple of examples of how these matrices are going to go. I want to give you, I guess that's 3 different examples we've done. I want to give you the special cases here because I want you to see, again, how this is going to look because sometimes weird stuff happens. So here's an example for that. 2x sub 1 plus 6x sub 2 equals -3. x sub 1 plus 3x sub 2 equals 2. Again, I don't know why they switched to the x1s and x2s, except that they're in matrices now and they think, oh, we have to be special for matrices. But it's still my x guy. This is still my y guy. That's still my equals. And on the right-hand side, I still have my constant. So I've got a 1, a 3, and a 2 on the second row. 2, 6, -3, and 1, 3, and 2. Make sure there aren't any copy errors. I think we're good to go. All right. So again, I see, hey, there's a 1 down here. So I'm just going to swap these 2 rows so that I can have the 1 on the top. It's minimal amount of work to do that, to just swap them. That's why it's one of the row operations. It's not something we normally do whenever we're working with actual equations, like if we were doing substitution or elimination, but for matrices, it works very nicely. Oh, I don't like the order they're in. Let's just switch the equations. As long as the entire 1, 3, 2 goes to the top, 2, 6, -3 goes on the bottom, and I don't lose any signs, we're good. Okay, I want this guy to be a 0, so I'm not going to mess up the top row. I'm going to rewrite him just the way he is, 1, 3, and a 2. Okay. What am I going to do? I think I need to multiply by -2 and add it down. Okay. -2 times 1 is -2 plus a 2 is a 0. -2 times 3 is a -6 plus a 6 is a 0. And I hope in your mind you just went, uh-oh, because in my mind I just went, uh-oh. Okay, so make sure we did it right. -2 times 1 is -2 plus 0 plus 2 is 0. -2 times 3 is -6 plus 6 is 0. Yes, we did it correctly. Okay. Keep going because we're not finished. But now we see, oop, this is one of those special cases. As soon as I see both the X and the Y went away, I'm like, okay, radar's peeled. Let's see what happens. -2 times 2 is -4. -4 minus 7, I'm sorry, minus -4 minus 3 is -7. It really doesn't matter what it is, because if this isn't a 0, we have a problem, right? Okay. So this is how these special case ones are going to look. You're going to end up with a problem. This says 0 equals 7. Okay. When is that true? Never. We know 0 does not equal 7. Okay. So when we get a never, that was a false statement. Or you could think no solution. And which situation was that? Parallel lines, right? Parallel lines, uh-oh, if they really are parallel, not like my two, look. Parallel lines are never going to touch. So there's never a solution. Okay, that's one of your special cases. And the way you know you got it is when you have 0 equals something that's not 0. Okay, that's never going to be true, which means there's no solution. Okay, so that wasn't a bad matrix problem, and it fell out pretty quickly, right? We saw really quickly, oh, 0 and 0 equals -7. Nope, that's not going to happen. So it's really a matter at that point of you being able to interpret that. And if you get things that are never equal to each other, that was parallel lines. That's a no solution. Okay, so just be aware that's what it looks like. Okay, so the other case is very similar. Let's see what it looks like. It's 2x sub 1 minus x sub 2 equals 4. And the second equation is -6x sub 1 plus 3x sub 2 equals -12. Okay. If you're really, really on top of it, you can see that's a multiple of the 2, that's a multiple of the 1, that's a multiple of the 4. If we're not on top of it, which sometimes we can see it, but we don't quite know what that means, it's okay. We can go ahead and work our way through this. This is 2, -1, and 4. And this is -6, 3, -12. Okay, set up my augmented matrix. 2, -1, 4, -6, 3, -12. I'm just checking for negative signs because I know that that's where I blow it a lot of times. So you should kind of check your negative signs also. It's an easy place to mess up. I don't see a nice easy swap or anything, so I'm just going to multiply this top row by 1/2. Okay. That's going to give me negative 1, or I'm sorry, 1/2 times 2 is 1. 1/2 times -1 is -1/2. 1/2 times 4 is 2. Okay. So far it looks okay. I didn't change the second row, so I'm just going to write it down. -6, 3, -12. I know sometimes it becomes a lot of writing and people want to shortcut it, but it really helps if you show every single step, because if you skip stuff, that's where we make mistakes. Okay, now I'm going to make that second guy be a 0, and I'll just tell you, usually if this is a special case, that's where we kind of see weird stuff happen. So make that second guy be a 0. I'm not going to change the upper row. I'm going to leave it the same. So I went ahead and rewrote that first row. And what can I do to get rid of that -6? I think I can multiply the top by +6 and add that down, right? So 6 times 1 is 6 plus 0, plus -6 is 0. Okay. 6 times -1/2. Well, that's a negative. Negative and positive is negative. 6 times 1/2 is 3. So -3 plus 3. Look at that. That's another 0. So Spidey senses are tingling here, I hope. But don't stop, because you don't know what happens until you do the last one. So 6 times 2 is 12. 12 plus -12 is 0. This is not the same situation we had a minute ago, right? A minute ago, we had, where is it? Man, I already messed things up. Here it was. A minute ago, I had 0 equals -7. I mixed that up too. But it didn't matter because a 0 is not a negative number. But now I have 0 equals 0. Hang on. 0 equals 0 there. That's true. That's always true. Oh, wow. This is one of those situations where we had a duplicate equation. I said that at the beginning, right? This kind of looks like this is times -3. This is times -3. This is times -3. And sure enough, they are. The second equation is just the first equation times -3. So it was the same solution for them. All the points, infinite number of solution, all the points work here. Okay. So what you'll see that they do in your book is they'll say, okay, or in the homework, I'm sorry, let x sub 2. And I don't know why they feel the need to substitute. I like to say let x sub 2 be any number. Okay. A lot of times they'll say let it be t. Okay, well, fine. Okay, so if if that is true, then what does this top row tell me? It just work your way through it. Okay. If x sub 2 is t, then x sub 1 equals oh, I'm sorry, x sub 1 minus 1/2. But they're substituting out, instead of the x sub 2, you could put the x sub 2 there, but they're in your homework, they'll put a t. I don't know why. So let me wait. Let me do x sub 2 equals 2, right? And so if I was doing this, I'd have x sub 1 equals 1/2 x sub 2 plus 2. That's the way I would write it, okay? But your book comes back and said, but let x sub 2 be equal to t. So they make this weird substitution here. Okay, x sub 1 is 1/2 of t plus 2. For my money, those are the exact same thing. They're just saying, let this substitution happen. I don't know why. I think it's fine to say, hey, the second variable can be any number. But they kind of like to make it make this substitution. So if you see that weird substitution step, that's what's going on. I don't really care so much about that. What I care about is you got right here. First of all, you got all the way to 0 equals 0. 0 plus 0 equals 0. That's 0 equals 0. And then in your mind, you need to stop for just a second and say, oop, what does that mean? And hopefully you know that what that means is, always true. This is infinite solutions. These are the same line. They just looked a little bit different to start out with. I hope that's how you see it. Hope that helps with your homework. Let me know if you have questions. Thanks.